Welcome back, everyone. I'm going to try pencil, and so I'm going to just see how that works. So, and if we can't see it, then I'll have to go back to pen, but I hate writing in pen. Math doesn't really go well in pen for me. So 3.339 is the problem that I'm going to be working for you now. And so what they're asking for here, they have capital F at x equals x times the square root of 6 minus x. And I'm going to go ahead, they're asking me to find in A through D all kinds of stuff. So they're asking me to find increasing, decreasing, local min, local max, etc. So the first thing I'm going to do is I'm going to find both derivatives, first derivative and the second derivative, because I have to do concavity, so I'll need the second derivative. Just to get that kind of out of the way, and then I'll go and answer the rest of the questions once we have those derivatives. So in order to find the derivative here, I have to use the product rule. So u equals x and v equals the square root of 6 minus x. I'll let you find the easier derivative here, and I'll find this hard derivative right here myself. And so have you guys got that one? I hope that you're thinking about it. So the outside function is the square root, and the inside function is 6 minus x. And I can take the derivative of the outside. It's 1 over 2 square root of the same darn inside, which is 6 minus x. And then times the derivative of the inside. The derivative of 6 is 0, and the derivative of negative x is negative 1. So f prime is, so we're on crisscross applesauce, right? So when we multiply those together, we get negative x over 2 times the square root of 6 minus x plus the square root of 6 minus x. And I think it would be better for me if I got a common denominator there. Thought about this as being over 1, right? And then multiplied here by 2 square root of 6 minus x divided by 2 square root of 6 minus x, so that I'll have a common denominator. So when the dust clears here, I'm liking the line paper better. I hope it's not too annoying for you guys, but it's better for me. And so I'm not even staying on the lines and it feels better for me. So that's kind of crazy. So when you multiply square root of times the square root like that, you're just going to get 6 minus x. And then the denominator here, you're getting 2 square root of 6 minus x. And now I need to move up. And, okay, and so now when I put these together, finally, I'm going to just put it over here to save my up space, my up, right? Minus x plus 12 minus 2x over 2 square root of 6 minus x, which is negative 3x plus 12 over 2 square root of 6 minus x. So there's my first derivative, and I'll put a box around it. I'm going to put it just down here. I was looking at it to see if it would reduce, because if it would reduce, I would want to reduce it with that 2, because these both can get a 3 out, but the 3 won't reduce with the 2. So no, you could do that, certainly, but I don't see the reason of doing that. Okay, now my computer is in the way of my up, and oh, I learned in algebra that I could sort of go up over it. Okay, so we'll try that. Now I'm going to find my second derivative, and I'm going to have to use the quotient rule. So u equals minus 3x plus 12, and v equals 2 times the square root of 6 minus x. I'll let you do this this easy derivative over here, and I'll do this one over here. That's my crazy joke, but it's making me feel happy to have some kind of a joke in these times. Doesn't seem like there's that much funny. So 2 times the square root is my outside function, and my inside function is 6 minus x. So when I take the derivative here, the 2 just holds still. So this is 2 times, and then the square root is 1 over 2 square root of the same darn thing, which is 6 minus x, times negative 1, right? So same kind, almost the same derivative as over there that we had. And so the 2 can be reduced out there, and I get negative 1 over the square root of 6 minus x. And now I have to tell myself, quotient rule, quotient rule, quotient rule. So, so when I do the quotient rule, I have to multiply u prime times v. So that's going to be negative 6 square root of 6 minus x. And then you subtract, and I'm going to write this, negative 1 over the square root of 6 minus x multiplied by negative 3x plus 12. Whatever order that made you happy to write that in, but I'm multiplying, you know, my u times my v prime here. And I wanted the negative 1 written first just because I was thinking that times that would be a positive. So that was my reasoning. And then I got to talking about this so much that I almost forgot divided by v squared. And v squared is, oh, now my book is in the way. And it's not going to be able to go up over the book. Okay, so, and my v squared is this. So 2 squared is 4, and the square root of the square root is just what's underneath there. So this is 6 minus x down there in the denominator. Okay, so I'm going to clean this up a bit here. So let's see what we have. We're going to have minus 6 square root of 6 minus x. And then, like I said, this plus, and then you have negative 3x plus 12 over the square root of 6 minus x, all divided by, where you can't see? Of course, I said I was going to move it up and move my book, but then did not move it up. So I didn't do anything here, but I said that was, oh yes, please. I've ordered my breakfast at this fine cafe, and so after I get this video done, my breakfast is going to be made, and I'm pretty excited about that. Okay, so that was a plus, and then I just had this, put this in the numerator over the denominator, and then I'm having my denominator down here. So I am going to be cleaning this thing up here by multiplying top and bottom here by the square root of 6 minus x, and also in the bottom the square root of 6 minus x. It's a complex fraction, right? So I'm going to clear it. Now when I multiply this numerator here to binomial, and I'm multiplying it by this monomial, square root of 6 minus x. So when I multiply that to this, that's like hot diggity dog, right? And so this thing is just some work to clean up. So minus 6, when you multiply those together, you get 6 minus x, plus, when you multiply this times this, the square root of 6 minus x cancels out, so you get negative 3x plus 12. I think I'll get rid of that plus sign. And in the denominator, divided by 4, and then now this is to the 1, and that's to the 1/2, right? That's 6 minus x to the 1/2. And when I add those together, the 1/2 and the 1, using the product rule for exponents, I get 6 minus x to the 3/2. Great. Okay, so cleaning up the numerator a little bit, and then I'll have my second derivative, and then I'll be able to go and do the stuff that I need to do with my first derivative and my second derivative. So let's see here. So cleaning up the second derivative, I could probably put that over here. So right, negative 36 plus 6x minus 3x plus 12 over the same darn denominator. And let's see here, that's 3x and minus 24. And I could factor out a 3, but it won't cancel with the 4 in the denominator. So it's good if you want to do that, or you don't have to. So there's my second derivative. Okay. Now, some other things that as I go to think about this just a little bit, this problem, when I go to start finding where it's increasing and decreasing and those kind of things, this problem from the beginning had issues with the domain. Because we know, so I'm going to just I'm going right back up here to the beginning here. Your book probably recommends you think about that first. And for whatever reason, I can't think about it until I start thinking that I'm going to find where it's increasing and decreasing and start thinking about where it's 0 and those kind of things. So the domain here is 6 minus x has to be greater than or equal to 0 because you can't have the square root of a negative. So that means that 6 has to be greater than or equal to x, or that x is less than or equal to 6. So I'm just going to remember that as I go on. Okay, so now I'm going to use, this is finally part A. So this is still 3.3, number 39, and now I'm finally going to do part A. And part A is, where is it increasing and decreasing? So what you need to do to answer that question is you need to look at where the first derivative is equal to 0 and where the first derivative is undefined. Those are your critical points. And so those will separate where things are increasing from decreasing. So my first derivative, minus 3x plus 12 over 2 times the square root of 6 minus x equals 0. And so the first thing I would do would be multiply by that denominator, and I'd multiply it times the 0, so it's really solving 3x plus 12, the numerator equals 0, right? Because that would just make the denominator go away. And so is that at 4? X is 4 is a critical point. Then I want to know where it's undefined, and it's undefined when the denominator is 0, which is at x is 6, right? And so the denominator of my derivative is 0, and that happens at x is 6. So, and remembering back to my domain was that x is greater than or equal to 6. So this technically probably is an endpoint and not a critical point, but it doesn't really matter that much what you're going to call it because the next thing is we're going on the number line. I like to use the first derivative test. You can use the second derivative test if you want, right? That's a possibility. But I'm getting to choose here. So I'm going to put on my number line here 4, and actually this is a stop here at 6, right? And then I want to do some testing in that first derivative, and I'm going to test right here. I'm going to test x equals 0, and all I care about is the first derivative, is it positive or is it negative? So here's my first derivative, and if I put in 0, the numerator is positive, the denominator is always positive, so this is positive. And if I check something in between 4 and 6, like 5, then, all I care about is it positive or negative. Now I got this question, and it was actually about the second derivative. They were asking on inflection points, but I do want to mention it right here. Someone asked, what if I get 0? And if you get 0, then you've made a mistake, because you are supposed to be having your zeros and your undefined points as your critical points, and you should be checking things that are not critical points. So if you get 0 here, if I put in 5 into the function, the derivative there, and I get 0, then that means it should have been a critical point, and I shouldn't be testing it. So anyway, so just kind of watch yourself on that. Anyway, and so that's the mistake there. You didn't get all the critical points. Okay, so this is negative in the numerator, and the denominator is always positive, so this is negative. So we know that over here was positive, and here was negative. So this means this is where it's increasing, and this is where it's decreasing. So they were asking us on part A, and so we know increasing, I'm going to just put it INC for increasing because I'm getting sick of writing the whole thing, is from negative infinity to 4, and decreasing from 4 to 6. Okay, and so Part B asked us about local min or a local max, and this is going up and then it's coming back down, and so this is a maximum, a local max, and we have that at f, capital F, because that's the name of this function, at 4. And remember to go back to f, not to f prime, to plug in. So f, remembering, look like this, x times the square root of 6 minus x. So I'm going to be putting in 4 here, and so that's going to be 4 square roots of 2. And so there's my local maximum, and I've written it in function notation, and I'm just going to go ahead and leave it in function notation. Then I'd like to know Part C. Part C, and I'm going to have to move up, is they're asking me probably inflection points and concavity, interval of concavity and inflection points. So now I have to look at the second derivative, and where the second derivative, so this is concave up and down, and inflection points, right? That's what they're asking us about here. Oh, local min, I forgot to say, was there isn't one, none. And so I kind of wanted to mention that. I usually give you an underline to put the local min on. And so you shouldn't just leave your underline blank, you should put none. I imagine in the back of the book, since there isn't one, they just didn't mention it or said there isn't one. I think it's better to say there isn't one. I don't know what they did though, I have to admit I didn't look. And so, I should have though. So f double prime equals 0, and when f double prime is undefined. So, so when we, I'm looking there for my f double prime that I found earlier, and so we're having here. So when that equals 0, the same reasoning that we have, we multiply that times that, so it's just the numerator, 3x minus 24 equals 0. So that's at x equals 8 as a critical number for the first derivative. And we want to know when it's undefined. And when it's undefined, if you do this work right here, you'll see is at 6, right? At x equals 6, which again is an endpoint really. And so then I like to put this on my number line. And I'm going to be testing in the second derivative. So I'm going to have did I make a mistake? I got 8, which is not in my domain. Yeah, that's not in my domain. I got to cross that out. So I only have 6 on here. I don't know what I got it in the law. Remember, I always forget about my domain and to check it. So when I was going to put this on the number line, I was like, wait a minute, what's going on here? And then I had to think about it. And so that's, now I only have one region. And so I'm going to test 0 into the second derivative because I want to know, is it concave up or concave down? So x is 0 into the second derivative is negative 0, that would be positive down there. And so this is a negative divided by a positive, in the second derivative is negative. So that tells us right here that this is concave down. So in part C, they asked us about concave up and concave down. So concave up, it's not. Ooh, here comes my breakfast, and I'm almost ready. It's never concave up. Concave down is from negative infinity to 6, and inflection points are none. And so that's that story. In part D, and then I'll be done with this video, and I'll get it rendering or whatever they call it when you do that, is to give a little sketch of it. So based on the stuff that you knew about it. And so we knew that it was increasing from 0 to 4. So when I draw my drawing here, at 4, we had a max up there at 4 square root of 2, right, times the square root of 2. And this thing goes looking, I was just trying to get another point on here when I sketch it. And so I was looking back at F, and I was thinking to myself, if I'm going to make a sketch of this, it would sure be nice to know the x-intercepts, and x is at 0 and x at 6, right? So I'm going to put those x-intercepts on here and at 6 right here. And then we knew that it was concave down everywhere and no inflection points. So I think it's just going to kind of go just like this. And then we know that it ends right there at 6. So there's a basic sketch of it, and we did a pretty nice job on that. And I hope that you guys are doing okay. Bye-bye.